welcome to the deep dive. Today we're really getting into a paleontological puzzle, focusing on a creature called Avisaurus.
Yeah, it's from the Late Cretaceous.
Right, you think about T-Rex, Triceratops,
Yeah.
but this one's different. It sort of blurs the lines between those big dinosaurs and, well, modern birds.
Exactly. We've got the research here, and it tracks Avisaurus from this initial fossil discovery that was a bit confusing,
Okay.
all the way to naming a brand new species just recently.
Wow. So our mission today.
Is really to figure out what Avisaurus tells us about life right at the very end of the dinosaurs. You know, the biodiversity then.
And how it fits into that whole dinosaur to bird evolution story.
Precisely. And there are some real aha moments here because this creature, it doesn't fit neatly into the boxes we expect. It kind of challenges things.
Okay, I'm intrigued. Let's dig in. So the story starts when?
1975. That's when the first bit was found.
And it was just a single bone.
Just one bone, yeah. Found in the Hell Creek Formation up in Montana.
Oh, Hell Creek. That's classic dinosaur territory.
Definitely. And this bone, it was a tarsometatarssus.
Which is, it reminds me.
Basically a fused bone in the ankle and foot area. You see it in birds.
Got it. So they find this bone, catalog it.
Yeah.
UCMP 117-600.
Right. But the interpretation, that's where it gets interesting. This one bone kind of sent researchers down a bit of a rabbit hole initially.
How so? What did they think it was?
Well, the first proper description came in 1985. Brett Sermon and Paul looked at it.
Okay.
And they concluded it was from a non-avian theropod. So like a meat-eating dinosaur, but not a bird.
Huh, okay. So definitely not a bird in their view.
Right. And then they took it a step further, which is pretty fascinating.
Oh.
They saw similarities between this Montana bone and another fossil found way down in Argentina.
Argentina. That's a long way.
Exactly. So they proposed this hypothesis. Maybe there was a land connection between North and South America back then in the Late Cretaceous.
Allowing Avisaurus, or something very close, to live on both continents.
That was the thinking. It suggests this really interconnected world.
Yeah.
Cool idea, right?
Yeah, really cool.
Yeah.
But maybe not quite right.
Well, that's science for you. Constant checking, reevaluating. The big twist, the real aha moment, came in 1992.
Okay, what happened then?
Louis Chiappe. He took another look at that original Montana bone.
Right, UCMP 117-600.
Yes. And his redescription found something crucial. They initially said it was a left tarsometatarssus.
Uh-huh.
Chiappe realized, no, wait, this is a right tarsometatarssus.
Left versus right. That seems like a small detail.
You'd think. But it changed everything. That different orientation, looking at it correctly.
Meant what?
It meant it wasn't a non-avian dinosaur foot bone after all. Chiappe recognized the features. This was from an enantiornithine bird.
Whoa. Okay, hold on. Enantiornithine.
Yeah, they're often called opposite birds. A really diverse, successful group of birds in the Cretaceous lived alongside the dinosaurs, but they had some key differences from modern birds, like in their shoulder structure. They didn't make it past the extinction event.
So the dinosaur bone was actually from an early extinct bird group.
Exactly. A total reclassification, a real paleontological plot twist.
And what did that do to the whole North America, South America connection idea?
Well, it kind of dismantled it, at least for Avisaurus, that Argentinian fossil. It was re-examined too.
Okay.
Turned out it was different enough, it got its own genus name, Saurosaurus.
Ah, okay. So two different, though related, types of birds on different continents. Not the same one spanning both.
Precisely. It just shows how careful you have to be. Comparing fossils. Details matter.
It really does highlight how science progresses. Sometimes you take a step back or even sideways to move forward. So let's focus back on Avisaurus itself. The main species is Avisaurus archibaldi.
That's the one. A. archibaldi is the type species, meaning it's the benchmark for the whole Avisaurus genus.
Named after the discoverer.
Yep, J. David Archibald. A nice tribute.
And when did this species live?
Late Cretaceous, right at the end. The Maastrichtian age. So maybe 70.6 down to 66 million years ago.
Literally among the last of the non-avian dinosaurs.
And these enantiornithines too, then. That's right. A. archibaldi is one of the very last known enantiornithine birds.
And was it small? Like sparrow size?
Oh, no, not at all. That holotype bone, the tarsometatarssus, it's pretty big.
How big are we talking?
Almost 74 millimeters long. That's nearly 3 inches.
Just for that 1 foot bone?
Yeah. For an enantiornithine bird, that's actually one of the largest known foot bones found so far. It tells us Avisaurus archibaldi was a decent-sized bird for its group.
Okay. Now, wasn't there another species? Avisaurus gloriae?
Yes, there was. That one was found in older rocks, the upper two Medicine Formation, so late Campanian age.
Also Montana.
Also Montana. But as we learn more about these birds, scientists realized Gloria was actually different enough from Archibaldi.
Different enough to be its own thing.
Exactly. So in 2018, it got moved to a new genus, Getia.
Ah, another reclassification. This story's full of them.
It is. It shows how the family tree gets refined as we find more pieces, more fossils.
It makes sense. And speaking of new pieces,
Mhm.
there's a brand new Avisaurus species.
Just named this year, 2024. Avisaurus darwini.
Darwini. Nice nod to Charles Darwin.
Definitely. And it's also from Hell Creek, like A. Archibaldi.
And what's special about Avisaurus darwini?
Well, one interesting thing is the size estimates that came with it. They estimate A. darwini weighed maybe up to 1.2 kilograms. That's about 2.6 pounds.
Okay, respectable.
And A. archibaldi, the type species, might have been even bigger, possibly up to 1.7 kilograms.
1.7 kilos. That's almost 4 pounds.
Yeah. For an enantiornithine bird, that's pretty hefty.
That definitely shatters the image of all early birds being tiny, delicate things hiding from the dinosaurs.
Absolutely. These Avisaurus birds were some of the heavyweights of the enantiornithine world. It suggests they were playing a different role in the ecosystem compared to their smaller cousins.
Right, like maybe filling different niches, hunting different things perhaps.
That's the implication. So, okay, we have these relatively large bird-like creatures living alongside T-Rex and company. What else can we figure out about them?
Well, you mentioned the family Avisauridae. Avisaurus belongs to that.
Yes. And what's cool is this family isn't just North American. It also includes related birds found in South America.
Like the Saurovisaurus we mentioned earlier.
Exactly. And others like Nucanornis and Intiornis. So this group, the Avisauridae, they were spread across parts of Gondwana, the ancient southern supercontinent.
Okay, so a widespread family. And most of what we know comes from this foot bone, the tarsometatarssus.
It's the main piece for Avisaurus, yeah. But you can learn a surprising amount from just that.
Like how it moved, its relationship.
For sure. The structure gives clues to locomotion, how it walked or perched, and it helps place it on the evolutionary tree. But maybe the most revealing feature are the claws.
Claws. What about them?
Well, the shape of the claws, at least inferred from the foot structure, seems to be inwardly curved, quite strongly curved.
Curved claws. That sounds familiar.
Like Dromaeosaurs, the group that includes Velociraptor.
Yes, like raptor claws.
Exactly. There's a striking similarity, and that strongly suggests
Predation?
predation, yeah. These weren't likely birds pecking at seeds.
So with claws like that, what would they be hunting?
Probably other vertebrates. Small reptiles, maybe amphibians, mammals, perhaps even other smaller birds. Think along the lines of a modern hawk or falcon, ecologically speaking.
A 4-pound hawk-like bird with raptor claws living in the Late Cretaceous.
That's a cool image.
It really is. And we know the environment it lived in thanks to the Hell Creek Formation.
Right, what was that like?
Pretty humid, low-lying, lots of swamps, lakes, river systems. It was coastal along the western edge of that big inland sea, the Western Interior Seaway, that cut through North America.
So a wet, swampy, coastal plain environment?
Yeah, teeming with life. We even have reconstructions, artist depictions based on the fossils.
Oh yeah, what do they show?
Well, one puts Avisaurus next to other contemporary flyers, birds, pterosaurs, and a human figure for scale. It really drives home its size.
Helps you visualize it. And another one shows Avisaurus darwini actually catching prey, talons sunken. It's a powerful reminder that the ecosystem wasn't just giant dinosaurs and tiny things scurrying underfoot. There was this whole middle ground.
Okay, so let's try and wrap this up. Avisaurus. It's a really compelling example of these late Cretaceous enantiornithine birds.
Absolutely. And its story, starting as a misidentified dinosaur bone.
Right, that whole journey shows how paleontology works. Discoveries, reinterpretations, classifications changing as we learn more.
And its size, its likely predatory nature, it adds so much texture to our picture of that final dinosaur ecosystem. It wasn't just the giants. These quite large specialized birds were there too.
That's the aha moment, isn't it? Realizing these weren't just background players. Some were significant predators in their own right.
Definitely. The whole process, from that first bone to naming A. darwini, it really underscores how science is this ongoing investigation, constantly evolving with new finds.
Yeah, it's never really finished.
So maybe a final thought for you listening. When you picture the late Cretaceous, T-Rex and Triceratops dominate, right?
For sure.
But what happens if you consciously try to shift that focus? Think about these other successful lineages, like the enantiornithines, like Avisaurus, these surprisingly large, clawed birds sharing that world.
Makes you wonder, what other hidden stories are still locked away in the fossil record? What other creatures are waiting for their aha moment?
Exactly. What else might we uncover just by looking closer or looking differently?